Page 7 of trig. This page is all about bearings. Bearings are a convenient way of using on maps to specify directions without a lot of extra words. Okay, so there's two ways to do this. The easier way is to define the direction as a 3-digit angle, like 120 degrees, 057 degrees, or 314 degrees. This is defined relative to the direction north. So remember, north is pointing up on the map, east is to the right, west is to the left, and south is down. And if, for example, you define 240 degrees as your bearing, 240 degrees is measured from north, so north would be 0 degrees, east would be 90 degrees, and you're going clockwise, 180 degrees for south and 270 degrees for west. So 240 degrees would be 180 degrees plus the difference, which is 60 degrees, so then it would be pointing like in this direction A here, okay? That's a 240 degree bearing, okay? Very compact. All you need to do is say 240 degrees and we already know that it's going in the southwest direction at this direction here, okay? There's another way, which is compass bearings. Compass bearings are a little bit more difficult. Compass bearings are specified relative to either south or north, depending on which direction you're closest to. If you are closer to north, the first thing that they're going to say is N for north, and then they're going to say how many degrees you are from north. So like you might be a few degrees to the left here or a few degrees to the right here. You would say the angle, so like you would say maybe like 45 degrees. And then you would say which direction. So are you going slightly to the left? That would be west. Or are you going slightly to the right, which would be east? So you would say either north or south. Then you would say how many degrees you diverge from north or south. And then you would say, are you diverging to the east or to the west? Okay? So that is much more difficult, I think. It's more likely that they would work with this type of bearing, the 3-digit bearing, on the IB exam. So let's look at a few problems, and we're going to focus more on drawing the picture than actually solving the problems, because once you get to the part where you solve the problem, it's pretty much like the previous pages. So I'm not going to go through and solve a lot of trig problems. I'm going to focus on drawing the picture. Okay. So first, a boat travels on a bearing of north 36 degrees west for 25 kilometers. Okay, so remember this compass bearing is defining that you're basically going north, so you're going up on the map, but you're diverging 36 degrees to the west. And remember, west would be that way. So you're going up, but you are going 36 degrees to the west. So that's slightly to the left, right? So this is the direction you're going. You're going this way here. How many miles north has the boat traveled? So we've gone 25 kilometers in this pink direction. How many miles north has the boat traveled? So what we're going to do is we're going to try to quantify this pink direction using a horizontal direction line and a vertical direction line. We're going to break it up into a horizontal component and a vertical component. The vertical component is going north and the horizontal component is going west, right? So how many miles north have we gone? Do you see how we've defined basically a trig problem? We have a right triangle, we have the hypotenuse is 25, and we want to know how far they've gone north here and how far later, how many miles have gone west. So we want to find each of these directions. If you know that this angle is 36 degrees, we can see that we can use SOHCAHTOA to find both this length and this length, because one of them's opposite and one of them's adjacent, and 25, of course, is the hypotenuse. So let's set up the equation to figure out this one here. Let's call this direction y. So if we want to figure out y, we would say, okay, I know that this is the adjacent to 36 and this is the hypotenuse to 36, so we would use cosine theta equals adjacent over hypotenuse. So the cosine of theta, we would use 36 degrees for theta, and that would be equal to the adjacent, which is y, divided by the hypotenuse, which was 25. So you know how to solve this from the last few pages. So that's how you would set it up, right? So that would be the answer to A. The answer to B you would find similarly, because this direction here is the opposite. So we would say sine of 36 degrees is equal to the opposite over the hypotenuse. So we would put the opposite as x and the hypotenuse 25, and we could solve for x the same way we've been doing on the last page too. Okay, so that was number 6. Number 7. Number 7 says a boat is due south of a lighthouse. Due south. What does due south mean? Due is describing how south you are. It turns out to mean exactly south. So if you're due south of a lighthouse, then that means you have lighthouse up here north, and then in a straight line going straight down, we're going to see a boat. So the boat is due south of the lighthouse. I've drawn it right there. The boat is sailing on a bearing of 292 degrees for 51 kilometers. So remember, if you have a 3-digit bearing, what that means is a angle that is measured from 0 degrees being north. So we're going to measure from this direction, and then we're going to go around in 292 degrees. So we're going to go around in a circle for 292 degrees. How far is 292 degrees? Well, remember, this is 270. So 292 degrees is even farther than 270. So you're going to be kind of in this quadrant over here, right? So it would be kind of looking like this. I'm going to draw this with a red pen. So let's say that this is 292 degrees. 292 degrees. And we went for a distance of 51 kilometers, okay? Until it is due west of the lighthouse. So the lighthouse is here. Due west of the lighthouse would be in this direction, right? So if we went 51 kilometers, they say that will put us in a position where we are due west of the lighthouse. So do you see how this would create a right triangle? How far is it from the lighthouse now? So this is another right triangle problem. It's a little bit tricky because we know that this angle is 292 degrees, but in order to use SOHCAHTOA to figure out, this is the hypotenuse 51, and this maybe is like the opposite or something, but we need to know this angle first, right? We need to know this angle, not this angle. So how is this angle and this angle related? You can see that when they add up together, they become 360 degrees. So we could find this angle here by doing 360 minus 292, which turns out to be 68 degrees. And that would allow us to figure out this distance here. We'll call it y. Okay? How far are you from the lighthouse if you go 51 kilometers until you're due west of the lighthouse? Okay? So we would be able to figure that out using SOHCAHTOA, right? And in this case, y is the opposite and 51 is if y is the opposite and 51 is the hypotenuse, so it would be right? It would be sine of theta equals opposite over hypotenuse. The theta would be 68 degrees. And then the opposite would be y, and the hypotenuse would be 51. So we could figure out y by putting sine 68 in the calculator and solving for y, right? Okay, let's move on to the next one. Number 3. A ship is sailing due north. A ship is sailing due north. So here's a ship. It's going straight north. The captain sees a lighthouse 12 kilometers away on a bearing of 0.36. A bearing of 0.36, remember, is a 3-digit bearing, so it means we're measuring from 0 degrees going clockwise. So this will be 36 degrees. And we see a lighthouse 12 kilometers away. There's the lighthouse, okay? Later, the captain observes that the bearing of the lighthouse is 125 degrees. So like after you travel north for a while, you look back at the lighthouse, and now the bearing is going to be 125 degrees. What does 125 degrees look like? Well, remember, this direction here is 90. So if this is 0 and this is 90, 120 degrees would be less than 180, but it would be more than 90. So it would be kind of be pointing back like that. So it would kind of be like this. Okay, so this would be measured from the north. So here to here, they're saying is 125 degrees. Okay, So now what we're doing is we're trying to figure out how far did the ship travel between these two observations. So we want this distance here, and the triangle that we've made here is not a right triangle, right? Let's see. So if we were trying to figure out this length here, let's call it x. We know this angle is 36 degrees. We know this distance is 12. This is a non-right triangle. So this is probably a cosine rule or sine rule problem. But how do we know if it's cosine rule or sine rule? Well, let's try to see which angles we have. We have basically this angle, and we have this side, and we'd like to know this side, and that's all we know. Okay, so if we tried to do sine rule, we'd be unable to do it because we don't know too many things, right? Now, we didn't use the fact that this is 125 degrees yet. Could we figure out another angle from this being 125 degrees? Of course we can, because these two angles here, 125 and this unknown angle, add up to 180, right? So I could find this angle here by subtracting from 180. That would be 55 degrees. So this angle here is 55 degrees. Now that we know this angle also, I think that we might be able to use sine rule, right? Because now we have these two, right? And do we know any other distances? We do know other distances. We want to know this distance, right? So do we know any other pairs? Well, do we know this pair? It looks like we don't, right? But actually, can't we figure out this third angle? Because we know two of the angles. We know two of the angles are 36 and 55. So we could actually figure out this angle by doing 180 minus 55 minus 36. That would give us what is it, 89 degrees? I think. 91. Yeah, it would give us 89 degrees. So actually we do know all three angles. Since we know all three angles, we do know these two pairs. So we could use sine rule to figure out what x is. Okay? That is a pretty difficult problem. Okay. Let's look at number 4. A hiker leaves camp and walks 5 kilometers on a bearing of 058 degrees. Okay, so this is a three-digit bearing, which means it's measured from north clockwise. 58 degrees is less than 90, so it would look kind of like this, 58 degrees. And he walks 5 kilometers on this bearing. He stops for a break, takes a break here, and then he continues walking for another 8 kilometers on a bearing of 103. Now remember, a 103 degree bearing, again, is measured from north, okay? And it's measured clockwise from north, and so 103 degrees, remember, is like slightly more than 90. So you would basically be walking back a little bit, and this would be 103 degrees, okay? He stops again before heading straight back. Find the distance back to camp after this drive. So he walks for 8 kilometers here. So this is like even farther. And then he stops, and then he heads back, which is this one here, okay? So, whoa, this is definitely a non-right triangle problem. And let's see, how can we figure this out? So we have angles that are outside the triangle, but we don't really have any angles that are inside the triangle, which is pretty challenging. Let's see. From these two lines, which are parallel to each other, we might be able to figure some of these angles out, okay? Like, for example, could we figure this angle out? So remember that if you have two parallel lines cut by a transversal, there's certain angles that are the same measure, and you can kind of see visually which ones those would be. Like all these blue angles are the same measure, and all these dark blue angles are the same measure. Okay, so in this case, if I extended this line a little bit, then this angle is the same as this angle, right? And can't I figure out that these two angles added up become 180, right? So this would be 180 minus 58, which would be 122, right? So if this is 122, this is also 122. And if this is 122 and this is 103, we could figure out this angle here, right? So 122 plus 103 is 225, right? 225. And to figure out what this remaining angle is, we would just subtract 225 from 360. So 360 minus 225 is equal to, let's see, 135. So this angle here is going to be 135 degrees. Okay, so now we know this angle, 135 degrees. We know that this side is 5, and we know this side is 8. And what we want to know is we want to know the distance back to camp, which is here. Okay, how can we figure out the distance back to camp? Well, we're definitely not using sine rule, right? Because like we don't have 2 pairs, or like do we? We don't have 2 pairs, and we don't have even 2 pairs if we include this side that we want, x, right? We don't know any other. Oh, I'm sorry, I drew the wrong thing there. If I'm going to draw a pair here, it has to be a side angle pair. So we only have this pair here. We don't have any other pairs because we can't find, from what I can see, we can't find this angle and we can't find this angle. So maybe we can use cosine rule. I think we can use cosine rule because we do have all 3 sides. We have names for all 3 sides, and we have 1 angle. So that's what cosine rule needs, right? So if we write down cosine rule, which is c squared equals a squared plus b squared minus 2ab cosine c, let's just label our sides. So for example, if we know that this is our special angle, our only angle, let's call that big C, and this would be a little c, okay? And then the A and B could be this and this, okay? It doesn't really matter which one's which. Now we can assign everything. So c squared is going to be x squared. We don't know what it is. A squared plus b squared would be 5 squared plus 8 squared. Then it will be 2 times 5 times 8, and cosine of angle C, which is 135. And then with this equation, we'd eventually be able to figure out the distance back to the camp. Okay? All right, those are the bearing problems. Good luck.